The frequency of a sound is expressed in cycles per second, or hertz. It is often referred to as the pitch of a sound. In this example audiogram, frequency is represented on the horizontal axis, with low frequency sounds on the left and high frequency sounds on the right. Thunder is a low frequency sound. And a bird's chirp is a high frequency sound. The loudness or volume of a sound is expressed in decibels. A healthy human ear can perceive sounds as quiet as 0 decibels. A normal conversation is approximately 65 decibels. And acute pain is usually experienced at approximately 110 to 120 decibels, which is the same as being 25 meters from a jet engine. An audiogram is a chart that shows the softest sounds that an individual can hear across a range of frequencies. This audiogram of familiar sounds shows the frequency and loudness of various sounds. A bird's chirp is quiet and has a high frequency. And a water drop is quiet but with a low frequency. A piano has a moderate loudness and medium frequency. A lawnmower is loud with a low frequency. And an airplane is very loud and has a high frequency. The highlighted area shows the sounds that are most important for hearing and understanding conversation. These sounds are usually between 125 and 8000 Hz. The letters M and N are low frequency sounds, while F and S are high frequency sounds. A hearing test measures how the ear hears different frequencies at different volumes. There are two types of hearing tests: air conduction and bone conduction. The air conduction test is usually performed first. It uses headphones or loudspeakers to analyze the functions of the whole ear, from the outer ear to the cochlea. A hearing test consists of listening to different tones, each with a unique frequency and loudness. To start, a given frequency is played at a very low loudness, and this loudness is gradually increased until the sound is audible. Each ear is tested independently, and the results are marked on an audiogram. In an air conduction test, a circle is often used to identify test results for the right ear. Next, the other ear is tested. An X is often used to identify test results for the left ear. If the air conduction test identifies a hearing loss, a bone conduction test is performed. This test uses an instrument that vibrates the bones of the skull to stimulate the cochlea in order to directly analyze how the cochlea responds to sound. The results of the bone conduction test are marked on an audiogram. In a bone conduction test, a right-angled bracket is often used to identify the right ear, and a left-angled bracket is used to identify the left ear. A triangle can be used to represent either ear. Here is an audiogram showing both air and bone conduction test results for each ear. If the bone conduction test results are better than the air conduction test results, this indicates that the cochlea is still functional and that the hearing loss is due to a blockage or deformity in the outer or middle ear. Your doctor or audiologist will be able to explain your audiogram in further detail.